All right, 20C, expectation. How are probability distributions used to make predictions? The expected mean value, the expected value or the mean value is the sum of the values for the random variable multiplied by its probability. So this symbol here, the sigma, means the sum. And you're going to take each x value, multiply by its probability, and you're going to do that for each x value. So if you have 4 x values, you'd be doing this 4 times, and would be 4. And then you multiply them all together, and then add them, and that's your expected value. So let's look at an example of what that looks like. Find the expected number of customers in Jamba Juice from 8 p.m. to 9 p.m. All right, so we have the expected, or the number of customers in Jamba Juice during that hour is either 0, 1, 2, 3, or 4. And then you can see each of those number of customers have their own probability. So we're just going to take the number of customers and multiply by its probability. And then we're going to find the sum. This symbol means the sum, so we're going to add them all together. So we get 2.86 customers. Now you might say you can't answer that because you can't have 0.86 of a customer, but for statistics, we can leave our answer like that because that's the expected number of customers. So we're going to leave it. We're not going to round more because we're going to leave our answer as an exact value or rounded to 3 significant figures. 2 dice are rolled 600 times. Find the number of times you would expect to roll a product of 36. So first we need to find the probability that we roll a product of 36. And there's only one way, and that's if, so this picture shows a red dice and a blue die being rolled, and all the different combinations. So there's only one way you can get a product to 36, and that's if you roll 2 6s. So that's 1 out of, there's 36 possibilities. So we're going to multiply that by 600 times. And that will be our expected number of times that we would get a product of 36. This is 16.6 repeating. And we can round to 3 significant figures. So that would be rounding to the first decimal, and that would be 16.7 times. Number 2, find the probability, or find the number of times you would expect to roll a product greater than 6. So we need to figure out how many times does a product greater than 6, or what's the probability that a product greater than 6 would happen. So all of these are going to be less than 6, so not those. Bigger than 6 would be from here down, not those. Bigger than 6, not those. Not that one, not that one, not that one. So we're going to count how many times out of 36 that this happens. I get 5, 10, 15, 19, and 19 plus 3 is 22. So 22 out of 36. Oops. And multiply that by 600. So 366.6 repeating times that we would expect to roll a product bigger than 6. If I round this number to 3 significant figures, 1, 2, 3, so I would bump this up to a 7, 367 times. The IB test that you take will ask for all numbers rounded to 3 significant figures, so we're going to be practicing that as we go. A random variable r has the probability distribution shown. If the expected value of r equals 3, then find the values for a and b. So I want you to think about this one. What do we know about probability distributions? We know the expected value is 3. And what do we already know about probability distributions? Well, we know that the probabilities all have to add up to 1. So we have a system of equations here. We have 0.1 plus a plus 0.3 plus b equals 1, which is 0.4 plus a plus b equals 1, or a plus b equals 0.6. So that's one equation. When you're finding two unknowns, you should have two equations. So we're going to have a system of equations here. So we know the expected value is 3, so that means 1 times 0.1 plus 2a plus 3 times 0.3 plus 4b is equal to 3. And I'm just going to simplify that probability or that equation. So I'm going to multiply 1 times 0.1, 3 times 0.3, add those together, and you get 1 plus 2a plus 4b equals 3, or 2a plus 4b equals 2. So now if I bring this equation down, I have a system of equations and I can solve that by elimination. So I'm going to multiply this one by -2. And I'm going to add it to 2a plus 4b equals 2. When I add it, the a's will be eliminated. I'm left with 2b equals 0.8, and I can divide by 2. So we get b equals 0.4, and if b equals 0.4, a plus b equals 0.6. I'm just substituting back into that equation. So that means a must be 0.2. So again, for this one, we used that probability distribution must always add up to 1. And we use the expected value. All right, a fair game is when the expected gain is 0. In a carnival game, it costs $5 to play. You spin the spinner below and win the amount it lands on. Is the game fair? Why or why not? Well, we can find the expected gain by taking the probability multiplied by the dollar amount. So we win $2, and the probability we win 2, that looks like it's about 1/4. Same with the $3, it's 1/4 chance, or 0.25. All the other values look like it's half of 1/4, so that would be 1/8. And we are going to find the sum. So we're just going to add them all together. So I factored out a 1/4, and then I did 2 plus 3, and I factored out a 1/8. I did 15 plus 10 plus 1 plus 4. So 1/4 times 5 is 1.25. And 15 plus 10, 25, 26, 30. So 30 divided by 8 is 3.75. And 1.5 plus 3.75 is $5. So the expected win is $5. So is this a fair game? Why or why not? Well, it is a fair game because it costs $5 to play. So everyone is paying $5 and the expected gain is $5. So that is the total. The expectation is that you would come out even at 0. So this is a fair game. All right, that's all.